Hello, ladies and gentlemen of geometry. We're looking at 6.6, and we are talking about the law of sines. This entire unit has been about triangles and trigonometry, special right triangles, and all those things. This is a rule that you can use anytime you have got a non-right triangle, and it is very, very helpful to help you figure out lengths and angle measures. But once again, it's got to be a non-right triangle, so that means if it's got a right angle, you cannot do this. Okay, this is only in non-right triangles. So first thing, cannot use on right triangles. You must have at least one side and the opposite angle, and it is the sine function only, and of course make sure your calculator is in degree mode. So here's kind of what the deal is. So you've got an angle and its opposite side, angle and its opposite side, angle and its opposite side. And the rule is that the sine of the angle divided by the sine, or divided by the side, is equal to the other angles over the other sides. Okay, so this is kind of the basic setup. The sine of the angle is over the side. Okay, sine of the angle is the side. So let's take a look here. Figure out the length of C. So we're going to figure out the length of C. This actually got cut off. This is supposed to say C is actually 50 degrees. So just write that on your notes that that's going to be 50 degrees, and then we'll kind of look at what we got here. So the first thing I want to do is identify what do I have any angles and their opposite sides? Well, yes, I do. I've got this angle and this side. So I can say, you know what, the sine of 42 over 12. So the sine of 42 over 12, that's going to be equal to the sine of 50 over C, because C is what we're trying to find. So now it just becomes a cross products problem, to where you're going to have C times the sine of 42 equals 12 times the sine of 50. Okay, so sine of 42, throw that in your calculator. That's going to be C times 0.6691. And then the sine of 50 times 12 is going to give you 9.1925. So then if I divide this by 0.6691, or if I just take that and go divide by the sine of 42, you're going to get approximately 13.738. So you can look at that and realize, okay, that's how big C is going to be. All right, C is going to be 13.78. All right, so now let's take a look at this. So here, let's kind of work backwards here, figuring out the angle of measure X. Well, again, first thing I'm going to do is look for what's my relationship. Well, I've got 125 and 100. Then I've got X and 60 that are kind of related. So my setup is going to look like this. Sine of 125 over 100 is going to be equal to the sine of X over 60. Okay, so what that's going to happen here is this. So 60 times sine of 125 equals 100 times the sine of X. So 60 times the sine of 125 is going to be 49.149. So what I'm going to do then is divide by 100. Which basically means I'm going to have 0.49149 equals sine of X. Now here is where I take sine inverse of that. Okay, so sine inverse gets rid of that. So I'm going to take sine inverse of that answer. So when I do that, I'm going to get 29.439. So that is approximately how big that is in angles. So that's how big that angle is going to be, about 29 degrees. So now, that's kind of your setup. Basically, once you get the sine of the angle over the side, all you're doing is doing cross products, multiplying diagonally and using some algebra. So now, technically, either way is correct to set this up. You know, you don't need all three. You only need two. I can only take these two or these two. I can take this one and this one. Either way is, any two out of those three are fine. And notice, I can put the sign on the top or the sign on the bottom. I like the sign on the top just because of, I like having angles on top and the sides on the bottom. To me, it makes more sense that way. You use whatever is you're comfortable with. That's kind of my preference. So here, what is the angle Allen creates with Brickton and Centerville? So what is this angle? Well, I know that this is across from 560. So if I look, Brickton, that makes a 60-degree angle, and that length is 512. So now, again, I'm looking for an angle, but take a look here. So 63 is across from 512. X is across from 560. My instinct says I think my answer should be a little bit bigger than 63, but we'll find out. So if I take the sine of 63 over 512, that's got to be the sine of x over 560. So that's going to be what my setup looks like. So it's 560 times the sine of 63 equals 512 times the sine of x. So when I do that, I get 498.96 divided by 512. So that's going to give me 0.9745. So that's going to be equal to sine of x. So I've got to take the sine inverse to just get x. And when I do that, I get 77.04 degrees. So that's how big that angle is in my problem. Okay, that's how big the angle is that Allen creates with Centerville and Brickton. It's going to be a 77-degree angle. Okay, so now taking a look, let's figure out, they want to know how big is side E. Well, I'm looking at this going, you know what, 54 and 7 look like a pretty good pair there. I'm going to work with that. So when I go over here, I'm going to move this over, I'm going to have sine of 67 over E equals sine of 54 over 7. So set up sine of 67 times 7 equals sine of 54 times E. So sine of 67 times 7 is going to be 6.443, and that equals the sine of 54 times E. So then if I divide by sine of 54, I get E to be 7.964. That's my answer. Which should make sense. 67 is bigger than 54, so it should make sense this side is bigger than 7. All right, let's take a look over here. Find the measure of angle F. So 50 and 12 is my setup. Angle in 8 is my other one, so I'm hoping my answer is smaller than 50. So I'm going to take sine of 50 over 12 equals sine of angle F over 8. So 8 times sine of 50 equals 12 times sine of F. So that's going to be 6.128. So if I divide by 12, divide by 12, that's going to give me a little bit more than 1/2. So then to solve, I'm going to take sine inverse of that. So it's going to give me an answer of approximately 30.7 degrees. All right, so get going on the practice, play around with this. Remember the high points, not to be used on right triangles, to be used on non-right triangles.